ओके आज चाहिँ हामी चाहिँ MBBS फर्स्ट इयर है MBBS फर्स्ट इयरको मोस्ट इम्पोर्टेन्ट टपिक है वान अफ द इम्पोर्टेन्ट टपिक अफ द MBBS फर्स्ट इयर जनरल एम्ब्रियोलोजीमा स्टार्ट गर्दैछौ हैन। सो अब तिमीहरूले चाहिँ यो स्पर्मेटोजेनेसिस है स्पर्मेटोजेनेसिस र oogenesis चाहिँ स्पर्मेटोजेनेसिस र oogenesis तिमी आफै पढ किन भन्दाखेरि यो 12 मा पढिसके अब म पढाउँदैन हैन। यो MBBS फर्स्ट इयरको हो यो। सो स्पर्मेटोजेनेसिस र oogenesis तिमी आफै पढ हैन। आज चाहिँ हामी कहाँबाट सुरु गर्छौं भने हामी सुरु गर्छौं फर्टिलाइजेसनबाट है सो फर्टिलाइजेसन सुरुमा डेफिनेसनबाट चाहिँ हामी व्हाट इज द फर्टिलाइजेसन। सो इट इज द process of union of female and male gamete है। process of union of female and male gamete कहाँ हुन्छ त भन्दाखेरि it occurs in ampulla region of uterus है ampulla region of uterus है। please do make notes है ampulla region of uterus। okay so एउटा uterus हेर्नु पर्दाखेरि if we draw the picture of the uterus it will look like this। okay these are the female right this structure is the structure of the uterus। okay and there is the endometrial lining okay there is endometrial lining and there is also the endometrial lining okay there is also endometrial lining okay this is the uterus, this is the structure of the uterus and there is the ovary okay and there is the primordial follicles. These are growing maturing that will result in the formation of the mature Graafian follicle okay this will result in the formation of the mature Graafian follicle okay this is mature Graafian follicle okay this will release the ova egg okay so it is surrounded by the layer of the granulosa cells or corona radiata and zona pellucida outside the ova and this is received by the female to the ampullary region. There is the ampullary region okay there is the ampullary region where the fusion occurs with sperm okay this sperm. So this fusion results in the formation of the zygote and this zygote travels via cleavage toward the uterus with cleavage to form a multicellular structure called morula marvelous shaped structure called morula and that finally reaches the uterine cavity okay uterine cavity okay यो भयो एउटा ओभरभ्यू दिएँ मैले फर्टिलाइजेसन पछि के हुन्छ भनेर। सो फर्टिलाइजेसन को खासमा एम के हो व्हाट इज द एम अफ फर्टिलाइजेसन इट इज इम्पोर्टेन्ट है व्हाट इज एम अफ फर्टिलाइजेसन इज द वन अफ द वाइवा क्वेशन अल्सो एम अफ फर्टिलाइजेसन। सो one aim is the restoration of a diploid number of chromosome is n for sperm ko n and the egg अथवा ovum ko n it gets fused to form 2n with a diploid so it restores the diploid number of chromosome okay one of the aim of the fertilization is to restoration of diploid number of chromosome and other aim is the Determination of sex. Okay, determination of sex. Sex is determined by fertilization. Either the X gamete of the male, X gamete, X male gamete, or Y male gamete fuses with the X gamete of the female. That will determine if XX fuses. They will the XX. This is the daughter, right? This will form a daughter. If YX fuses with XY, this is the son, right? Okay, this is the son. So determination of sex is also the aim of fertilization, and the fertilization proceeds via cleavage. There is the initiation of cleavage. There is initiation of cleavage. There is initiation of cleavage. Okay, there is initiation of cleavage. There is determination of sex. There is restoration of diploid number of chromosome. So 3 aims. And okay, another topic is the motility of sperm from cervix. Okay, motility of sperm from cervix to uterine tube. Uterine tube. How is the sperm traveled from the cervix to the uterine tube? Okay, this is the structure of the your uterus, your female uterus. Structure of the uterus of female. Okay, this is the ovary. These are the ligaments. Okay, this is the structure of uterus. A little bit. Let's make that. Okay, female, and there is the ovary, and there is ovary, and this is the uterus. Okay, this is the uterus, and there is cervix. This is the cervix. So sperm is deposited during intimacy. Here sperm are deposited, and this sperm has to travel this distance. Okay, this sperm has to travel this sperm has to travel this distance. Okay, here up to here. This is the ampullary region. This also travel there. There is the ampullary region. So for this, what facilitate the sperm to move from the cervix to the ampullary region of the uterus? Okay, what facilitates? Okay, there is a muscular contraction. There is a muscular contraction. Muscular contraction of uterus and uterine tube. Muscular contraction of uterus and uterine tube. One is, and another is the by its own propulsion. By its own propulsion, by this zigzag movement. Eh? So its own propulsion and the muscular contraction of the uterus and the uterine tube. Eh? Okay, so what changes should be done to the sperm before fertilization? Changes in sperm before fertilization. Before fertilization, what should be changed in sperm to fertilize the secondary oocyte? Okay, there should be two things. Two things should be changed. That is a capacitation. One is capacitation, and another is acrosomal reaction. Capacitation and acrosomal reaction. Right? So, what is capacitance? So, it is the ability. It is the gain of the ability. Is the gain of ability of sperm. Gain of ability of sperm to fuse with secondary oocyte. Only capacitated sperm can fertilize secondary oocyte. So the period of conditioning in the female labor tract in the uterine tube and the uterus. So this is the epithelial interaction. This is also the epithelial interaction. This is also the epithelial interaction between sperm and uterine tube. Sperm and uterine tube that facilitates that make the sperm capable. That makes the sperm capable of penetrating corona cells and undergo acrosomal reaction. Okay, so what is acrosomal reaction? This is the reaction that is the acrosome is a modified Golgi complex. It's a modified Golgi complex that contains hydrolytic enzymes. Many hydrolytic enzymes that are needed for the penetration of sperm to secondary oocyte. So this sperm acrosome contains most of the hydrolytic enzymes such as hyaluronidase, zona lysine, etc. This hydrolytic enzymes helps in the penetration of sperm to the secondary oocyte. And there are certain phases of fertilization. Okay. There are certain phases of fertilization. Okay, that's the phase 1. Phase 1 is the penetration of corona radiata. And phase 2 is penetration of zona pellucida. And phase 3 is the penetration of the fusion of secondary oocyte and sperm cell membrane. Sperm cell membrane. Okay. There is the secondary oocyte. The typical structure of the secondary oocyte looks like this. Contains a polar body. And is surrounded by the zona pellucida. Okay, this is surrounded by the zona pellucida, outer covering of the secondary oocyte. This is the outer covering, zona pellucida, and zona pellucida is further covered by the corona radiata cells. These are further covered by the corona radiata cells. Okay. These are the corona radiata, and for the sperm to penetrate, first it should penetrate the corona radiata, that is the phase 1, and then it should penetrate the zona pellucida, that is phase 2, and the come in contact with the membrane of the secondary oocyte, that is the phase 3. So these 3 phases of the fertilization are like this. When it penetrates the zona pellucida, penetration of zona pellucida by one sperm activates the peripheral cortical granules and make zona pellucida impermeable for other sperms that prevents polyspermy. Okay, when the zona pellucida is penetrated, that activates the peripheral cortical granules. That make zona pellucida impermeable for other sperms. That prevents the polyspermy. Okay. Then this reaction is known as zona reaction or cortical reaction or zona reaction. This reaction is known as cortical reaction or zona reaction. And when the sperm is fused with oocyte membrane, secondary oocyte membrane, the secondary oocyte resume its second meiotic division and convert into the female pronucleus. And this, the nucleus of the sperm, that is the male pronucleus and fuses with the female pronucleus to form a diploid zygote. That is 2N. And this diploid zygote is the initial diploid cell that is formed after fertilization, and that will lead to the formation of the fetus. And embryo and fetus. Okay, embryo, then fetus. Okay. There is the we start the first week of development. So after fertilization, there is the first week of development. That is the after fertilization up to the 7 days. Fertilization up to day 7. Okay, fertilization up to day 7. So the first event in the first week of the development is the cleavage. So cleavage are the rapid mitotic divisions. These are the rapid mitotic divisions, and this will lead to the formation of the two blastomeres. So cleavage results in the formation of the blastomeres, and these cells, the cleavage is the product of cleavage base are blastomeres attached to each other because they cannot move out of a strong covering called zona pellucida. So there is outer covering of zona pellucida that covers the blastomeres, and that prevents the separation of blastomeres, so that the formed blastomeres are obviously they are smaller than their precursors. so than their precursors. These formed blastomeres are smaller than their precursors. So this is the diploid zygote, which is surrounded by the outer covering of the zona pellucida. The zona pellucida, and this will lead to formation of this two-cell stage. There is a two-cell stage. Two-cell stage, and this will lead to formation of the again zona pellucida, and this will lead to formation of the four-cell stage. Four-cell stage. This four-cell stage, and this will lead to formation of the eight-cell stage. This will lead to formation of the eight-cell stage. Eight-cell stage. This is the two-celled. This is the zygote, and there is the first cleavage. That will form in the two-cell stage. Two-celled stage, and there is second cleavage. That will form a four-celled, and there is a third cleavage. Eight-celled. After a cell, the adjacent cell gets more compacted. The adjacent cell gets more compacted to form a solid ball-like structure. Adjacent cells are more compacted. Right? There is the phenomenon called compaction. To form a solid ball-like structure. This will form the solid ball-like structure, and it will form the 16-cell stage. This is 16-cell stage. And this 16-cell stage also known as little bit look like the mulberry. So mulberry, it is known as mulberry stage or morula. After 16, it will come on 32-cell stage. Okay, and there is outer covering. Obviously, there is outer covering of zona pellucida. Okay, there is a compaction after the third cleavage. There occurs compaction. After the third cleavage. So after the eight-cell stage, there occurs a compaction between the adjacent blastomeres to form a solid ball-like structure. Okay, this is called the compaction. And the morula, the resulting morula, is a 16-cell stage. That morula is still covered by the zona pellucida. And after 32-cell stage is the embryo, is the product of cleavage. Begins to migrate towards the uterus. So it will migrate towards the uterus. And the fluid from uterus just begins to penetrate. It will begins to penetrate through the zona pellucida, and it will accumulates in the intercellular species. Intercellular species of inner cell mass. This will lead to the formation of a fluid-filled space. Known as blastocell. And this stage is known as blastocyst. And this fluid-filled cyst-like structure, cyst or ball-like structure, is known as blastocyst. And this stage is known as blastocyst stage. Okay, blastocyst stage. This stage is known as blastocyst stage. So blastocell is the fluid filled cavity. Blastocyst is the solid ball with inside the fluid filled space blastocell, and blastocyst stage is the stage where the blastocyst is formed. Okay. The blastocyst. So typical structure of blastocyst looks like this. This is the typical structure of blastocyst, where it contains the outer cell mass. It contains the outer cell mass. This is outer cell mass of a blastocyst, and there is the inner cell mass. Inner cell mass. Okay. The inner cell mass, and there is a full filled space known as blastocell. So this is the outer cell mass. This is the outer cell mass. Outer cell mass. This is the inner cell mass. This is inner cell mass, and this is the blastocell. Blastocell. And the whole structure is known as blastocyst. So around the 4th to 5th day, 4 to 5 days after fertilization, blastocyst is formed. Around the 4 to 5 days after fertilization, blastocyst is formed. Okay. So in your outer cell mass or inner cell mass. So at the 5th day of after fertilization, there is a differentiation of the outer cell mass and inner cell mass. And inner cell mass. So outer cell mass. This outer cell mass forms the trophoblast. And this inner cell mass forms the embryoblast. Outer cell mass forms the trophoblast, and inner cell mass forms the embryoblast. So blastocyst is formed within 4 to 5 days after fertilization in the uterine cavity. Okay. So what is the nutrition obtained? What are the nutritions of the blastocyst? Nutrition are the uterine glandular secretion, and nutrition of blastocyst is Blastocyst nutrition is the uterine glandular secretions. Uterine glandular secretions. These are the nutrition of blastocyst, and it is also enveloped by zona pellucida. It's also enveloped by zona pellucida. Okay, I will draw the zona pellucida. It's also enveloped by the zona pellucida. The outer covering is also enveloped by zona pellucida, and okay. So at the 6th day, after fertilization, okay, after fertilization at the 6th day, there occurs the implantation of blastocyst. Implantation of blastocyst on the uterine wall. Or there occurs the hatching of blastocyst from zona pellucida. Okay, that is the okay. This is the blastocyst. This is the structure of blastocyst. Typical blastocyst is like this. Oh, this outer cell mass. And this is the inner cell mass. This inner cell mass. Okay, this is inner cell mass. Outer cell mass. And the outer cell mass around the embryonic pole. So where is the embryoblast? This embryoblast, and this is the trophoblast. Okay, trophoblast. This is the trophoblast, and this is the embryoblast. So the pole towards the embryoblast is known as embryonic pole. This is the embryonic pole, and the pole opposite to the embryonic pole is abembryonic pole. embryonic pole. Okay, and the trophoblast towards the embryonic pole proliferates and form a projected projected structure like this, and this structure are known as the proliferating trophoblast cells. These are the proliferating trophoblast cells. So at the 6th day, this proliferating trophoblast cells erode the maternal uterus wall. This erode the maternal uterine epithelium. Maternal uterine epithelium by binding to certain selectins and it will help in the anchorage of the anchor the blastocyst to the uterine wall and help in the implantation of blastocyst. So implantation of blastocyst occurs at 6th day after fertilization. Okay, this is the concept. And the certain selectins and their receptors on the trophoblast cells mediate this attachment, and the blastocyst gets implanted. So which phase of uterus is uterus at the time of implantation? Uterus at the time of implantation. So uterus at the time of implantation is in secretory phase. This is in secretory phase. Okay, secretory phase. So secretory phase begins after 2 or 3 days. It begins 2 or 3 days after ovulation. So for a normal female cycle of 28 days, ovulation usually occurs in 14th day. So the secretory phase begins from the 16th or 17th day and lasts up to the 28th day. So this period the uterus is in secretory phase, and so after ovulation the Graafian follicle changes to the corpus luteum that secretes the progesterone. So that progesterone help in the maintenance of the help in the proliferation of uterus, and maintenance of uterine gland. That help in the proliferation and maintenance of uterine gland. That help in the increase in thickness of endometrium. That help in increase in thickness of endometrium. And okay, so as a result, the uterus wall, the endometrium, has 3 layers. So endometrium during secretory phase has 3 layers. Secretory phase में 3 layer. Okay, this is a superficial compact layer. And intermediate spongy layer. Intermediate spongy layer, Okay, a intermediate spongy layer and a thin basal layer. A thin basal layer. So basal layer is a regenerative layer. The regenerative layer. So during menstruation, these two upper superficial and intermediate layer, that is this compact layer and spongy layer, gets slowed off during menstruation, and the basal layer remains there and it's proliferate in the secretory phase again after the ovulation in the next cycle. If fertilization does not occur, if fertilization does not occur, okay, if fertilization does not occur, fertilization, if fertilization does not occur, then what happens? Okay, if fertilization does not occur, the corpus luteum degenerates. Corpus luteum degenerates, and the estrogen and progesterone level falls. Estrogen and progesterone level falls, and menstruation occurs. Menstruation occurs. Okay. Okay, this is spongy and compact and spongy layer are slowed off. Compact and spongy layer are slowed off with blood of approx 50 ml. This compact and spongy layer are slowed off and with blood of approx 50 ml.